this section, we're going to be looking at factoring polynomials who have a leading coefficient other than 1. This comes from section 6.3 out of the textbook. In order to be able to complete this section, you need to know how to find all factors for numbers. You need to understand rules for operations with signed numbers, and you need to understand how to multiply binomials. Trinomials that have a leading coefficient other than 1 range in level of difficulty from super easy, to where you have a 50-50 chance, to really hard, where you have lots of possibilities that you need to consider. This material I'm going to present in different segments based on 3 levels of difficulty. When working with problems that have a leading coefficient that is not 1, here are some starting hints to help you out. Stop and analyze the problem. Determine the difficulty level and a technique of your choosing to solve it. Put away your eraser. If your check step doesn't work out, don't erase it. Students who do this are likely to keep trying the same 3 or 4 possibilities over and over. Speaking from personal experience on that one. As we progress through difficulty levels, I will tell you my 3 basic rules of factoring trinomials and the reason that they exist. These rules were not taught to me, but rules that I came up with based on observations and doing many problems. So one thing I want to tell you is I don't believe in using tricks. I'm going to explain exactly why we do what we do, and hopefully that'll help you understand these problems a little bit more. Now I will tell you that I do present this differently than most other instructors, than most textbooks. So if you have any questions, please make sure that you do bring them to me so that I can either explain other methods that you can use to solve these problems, or I can show you how I would do it. In this first portion of the presentation, we're going to look at level 1, where A and C are prime. If A and C are both prime, then there is only one way to break down each number. Basically 1 and the number itself. The problem then becomes where to put these numbers, and we still need to talk about our signs. So we want to always place our numbers first. If the signs are different, note that the sign of the middle term doesn't necessarily go with the larger number, but the larger quantity in terms of our outsides versus insides. Let's look at another example. Second example that we're going to look at is 3x squared plus 14x minus 5. Our next example that we're going to look at is 3x squared plus 14x minus 5. We can again begin by writing our 2 sets of parentheses. And as I said, we got a 50-50 shot here, so I'm going to write out 2 different problems. The only things that multiply to 3x squared is 3x and x. I'm going to go ahead and put those in for my firsts on both of them. The only thing that multiplies to 5 is 1 and 5. And so I'm going to go ahead and place my 1 and 5 in my set of parentheses, reversing them on the second one. We know that we want to multiply to a negative, which means that we need different signs. And I want my larger quantity to be positive. So when looking at our outsides and our insides on the first one we have our outsides is 3x, our insides is 5x. Since 5x is larger, that means that I want that to be positive and my negative, or my 1 to be negative. On the second one, my outsides come out to 15, my insides come out to 1. My outsides are larger, so I'm going to make the 5 positive and the 1 negative. Now we want to go ahead and FOIL and check these. If we FOIL the first one, we get 3x squared minus 3x plus 5x minus 5. We can combine our like terms, and we get 3x squared plus 2x minus 5. That is not correct. For the second one, we get 3x squared for our firsts, 15x for our outsides, minus x for the insides, and minus 5 for the lasts. If we combine our like terms, we get 3x squared plus 14x minus 5. That is the correct answer. And so our correct factorization is 3x minus 1 times x plus 5. Let's look at the next one. Again, we have a 50-50 shot, so I'm going to go ahead and write out 2 sets of parentheses times 2. The only things that multiply to 2x squared is 2x and x. So I can go ahead and put those in my firsts on both sets. The only thing that multiplies to 3y squared is 3y and y. And so I'm going to go ahead and place y and 3y in the first one, and then flip it in the second one. Since 3y squared is positive, that tells me same signs, and I want to be able to combine to a positive 5. Both of them will be positive, so we can put pluses in all of our factors. From there, let's use FOIL to determine which one is the correct answer. For the first problem, when we FOIL, we get first is 2x squared plus outside 6x, y, insides is xy, lasts is 3y squared. If we combine like terms, we get 2x squared plus 7xy plus 3y squared. For the second one, we get 2x squared for our first, 2xy for our outsides, 3xy for our insides, plus 3y squared for our lasts. When we combine, we get 2x squared plus 5xy plus 3y squared. The second one is the correct answer, and so we will go ahead and keep it. Let's look at one last example. We have 2y squared plus 3y minus 2. We'll start by writing our sets of parentheses. From there, we are going to go ahead and factor 2y squared, which breaks down into 2y and y. Let's put that in both of our examples. Minus 2 is going to be 1 and 2, or 2 and 1 apparently. So let's go ahead and put 2 and 1 in each one, and the second one we'll flip it around. From there, we want to multiply to a negative 2, which tells me different signs. With different signs, I want to be able to subtract to a positive 3, which means that my larger quantity will be positive. If we look at the first one, our outsides and our insides, well, they're the same. So I think we can go ahead and safely rule this out. This is a violation of one of our rules that I will go ahead and mention in the next slide. So that does leave us with 2y, 1, y, and 2. If we look at this, our insides we get 1y, and our outsides we get 4y. Since 4y is larger, then that is the one that we want to be positive. So I'm going to put my plus sign with the 2, my minus sign with the 1. If we go ahead and FOIL this, we get our first is 2y squared plus our outsides 4y, insides is minus y, last is minus 2. If we combine our like terms, we get 2y squared plus 3y minus 2, and it checks. So our final answer is 2y minus 1 times y plus 2. One thing to note is that since we are not doing this in class, I did go through all the possibilities. One thing is that you can always guess and check. Trial and error is the most classic way of teaching factoring. Now, if you manage to get it right on the first try, then fantastic, you're done. But if you don't, you can always make an adjustment and then try it again. When we finish this presentation, I will present the 3 rules of factoring according to me, and you can also use those for these particular examples. So after finish watching the slide, go back to this slide and see if you can use some of those rules to help you figure out what factorization would be correct from the very beginning. Okay, let's start by looking at some examples. Now, as I said, I'm going to go ahead and show you both ways that you might set up the problem, and then we'll go from there and explain why we want to do one thing over the other in terms of what should we do in order to get to the right answer faster. So as I said, these are all going to be level 1 difficulty levels, only because there's a 50-50 shot. You got a 50-50 shot because the first number and the last number are both prime. So that means that each one of these numbers only breaks down one way. So in the previous section, we always made sure that our firsts were always x and x. But now that we have a coefficient, we do need to make sure that we break down the number as well. So 5x squared, in order to break that down, that's going to be 5x and x. 7, the only way that 7 breaks down is 1 and 7. And so if we go ahead and put our numbers in randomly, put them wherever you want, then we can go ahead and continue. Again, I'm just guessing here. So we have this as one possibility, and our other possibility is 5x and 7 in the first set, and x and 1 in the second set, just switching my 1 and my 7 around. Now we do still have our same rules in terms of signs for the most part. Here, since we are multiplying to a positive 7, then that means that my signs are the same. Both are going to be positive. Now when your signs are the same, it doesn't matter whether you do this first or last, because you know automatically what your signs are, you know where they go because they're the same. Okay? It's when they get different that we do have to look at that in a little more carefully. And we'll see some examples of that coming up shortly. Okay, so let's go ahead and multiply these out and see what we can do. So for the first one, if we multiply out, we want to FOIL, so we get our 5x squared. Outsides, we get 35x. Insides, we get plus 1x, or just x. Last, we get 7. In the middle, we end up with 36x. But that's not what we wanted. Okay, so now let's go ahead and look at our second factoring and see if that one is correct. So if we multiply this out, we get 5x squared plus 5x plus 7x plus 7 using FOIL. In the middle, we do get 12x. So the correct answer, our correct factoring, is 5x plus 7 and x plus 1. All right, before we analyze these, let's go ahead and try another example and see what we come up with. So the next example, B, we have 3x squared plus 14x minus 5. Again, our first and last terms are prime. So we do have 3x squared breaks down to 3x and x. We have 5 breaks down to 5 and 1. And the other possibility that we have is 3xx, and we can flip our 1 and 5 around. Now this one we do need to be careful because we do have different signs. For now, I'm just going to go ahead and put them in randomly. So I'm going to put the plus with the 5, and I'm going to put the minus with the 1. In the second one, I'm going to put the plus with the 1 and the minus with the 5. Again, I'm just doing this randomly just to put them there. We can always make changes if we need to. Okay, so for the first example, let's go ahead and multiply out. We get 3x times x for our first is 3x squared. 3x times negative 1 is negative 3x. Insides, we get 5 times x is 5x. Lasts, we get minus 5 times 1 is 5. This results in a middle term of 2x, which is not what we want. So the numbers are not in the correct places. Okay, so let's flip our numbers around and then try it again. So if we do this one, we get 3x squared for our firsts, minus 15x, plus x minus 5. And when we combine, we get minus 14x. This is closer, but still not quite right, because here I get up with negative 14, where I originally wanted a positive 14. So what can we do in order to fix it? Well, we need to switch our signs. So our actual factorization is I want to make the +1, I want to make it a -1, and I want to make my -5 a +5. If you multiply this out now, we get 3x squared plus 15x minus x minus 5, which does in fact give me 14x. And so this one is our correct factorization. Okay, so let's analyze these. So for the first one, why is this not a good factorization for example A? Well, notice that we get too large of a value in the middle. And the reason that we get too large of a value is because we're multiplying 5 and 7. 5 and 7 is 35, which is far away from 12. And so for instance, when I factor this from scratch, I look at 12 and think 12 is a pretty small number, so I probably don't want to multiply 5 and 7 together. If you don't want to multiply them together, then you don't want them in the outsides or the insides, which means that you want them in the same factor, like we did here. Notice I put my 5 and 7 together, which means that I'm going to be adding them, which gets me to 12. For example B, why don't we want them in the same set? Well, 3 and 5 actually multiply to something closer to 14 instead of adding. And so since 14 is a rather large number in comparison to 3 and 5, I want to multiply them together, meaning I want them in different sets. I want them to be outsides or insides. The other thing to note is that note that we are subtracting to 14, which does mean different signs, and we want our larger quantity to be positive. Well, since our larger quantity is our outsides, that I want to be positive instead of my insides. Note on the previous one, we got -14 because my larger quantity, I made that negative. Let's look at a couple more examples. So if we look at C, 2x squared plus 5xy plus 3y squared, I know my 2x is going to be 2x and x, and my 3y, I'm going to go with y and 3y. My signs are the same, and they are both positive. If we multiply this out, we get 2x squared for our firsts, plus 6xy, plus xy, plus 3y squared. And if we combine, we get 7xy in the middle, which is not what we wanted. So let's flip the numbers. Let's go with 2x plus 3y and x plus y. Here we get 2x squared plus 2xy plus 3xy plus 3y squared. And now my middle terms, I do get 5xy. And so this is the correct factoring. So note, this is kind of a tough one. This is one that you kind of got to just go with it, try it and see. Because either way, our middle term is going to be relatively small. But for this one, to get to 5y, I want to add 2 and 3 instead of multiply them. And so this is why we get the second one is the correct factoring. So now let's look at D. D, for my firsts, I'm going to have 2y and y. And then the 2, I'm going to break it down to 2 and 1. So let's see here. I'm just going to put my signs in randomly and see what happens. I do know that they are different, and so I'm going to go with -2 and +1. So if we FOIL this out, we get 2y squared for our firsts, plus 2y for our seconds, minus 2y for our insides, and -2 for the lasts. And, well, we have something happen here that we shouldn't have happen. Our middle term cancels. Well, this is another rule that I have in terms of how to do factorizations. And the other rule is that you cannot have common factors in the same set of parentheses because you can factor it out. And if you can factor it out in your factorization, then you should have been able to factor it out from the very beginning. But note, in the very beginning, we don't have a common factor of 2. So this is one that will rule out a lot of possibilities. I know for a fact that my 2 has to go in the second set because it can't go with the 2y. They have common factors. Okay, so I'm going to go ahead and put my numbers in like this: 2y and 1, y and 2. And then now I want to go ahead and put in my signs. Now I want my larger quantity to be positive. So which one is larger, outsides or insides? Well, my outsides is larger, so I'm going to make that a +2 and a -1. So now if we FOIL this, let's go ahead and see what we get. For our first, we get 2y squared. Outsides, we get 4y. Insides, we get -y. And last, we get -2. And this does, in fact, give us 3y. So this is the correct factorization. Go ahead and try the following problems on your own using some of the things that we talked about. See if you can figure them out on the first try.